Global Analytics for Bridge Management is an innovative bridge management tool researched and developed by UBM's Research Group, or URG in short. Global Analytics for Bridge Management, or GABM in short, has been evolved by URG in the year 2023 post-collapse of Morby Bridge. GABM empowers micro-inventory owners as it is cost-efficient. Heavy rainfall, landslides, cyclones, earthquake and similar natural hazards have affected numerous regions in India during the last year. These occurrences have shown that natural disasters are becoming more unpredictable and severe. Several bridges have collapsed due to the impact of natural hazards. Calamities occur when bridges collapse. Forces of natural hazard combine with the distress and deterioration in bridges, resulting in a collapse. However, such collapses are avoidable. GABM provides you with the edge to avoid a natural hazard becoming a calamity on your network. GABM is a bridge management analytics software used to mitigate the impact of natural disaster on bridges. GABM applies systematic assessment using advanced algorithm which links the deterioration in the bridge to the impact of the forces of natural hazard. This results in risk assessment for the bridge. GABM incorporates natural hazard disaster mitigation and also ensures disaster resilience for the entire lifetime. GABM enables evaluation of the deterioration model during the initial lifespan of the bridge, by a symptom-based evaluation process. As the age of the bridge progresses, symptoms alone cannot help evaluation of the deterioration process. The cause-based evaluation process within GABM makes it possible. When the age of the bridge progresses beyond 50% of its design service life, performance evaluation is essential. GABM has structural health monitoring assessment for such aging bridges. Real-time data is required for swift interventions and adjustments during natural disaster. Advanced algorithm to evaluate bridge deterioration process during disaster scenario within GABM makes it possible and provides the required base for evaluation of balanced service life for entire lifespan for the bridge. GABM can also use 3D modeling and photogrammetry for precise identification of distress zones. URG has evolved GABM, which is very cost-efficient and technically advanced. GABM now has facilities to import and export data. Bridge inspection input has artificial intelligence-driven evaluation of structural ratings and cause matrix evaluation from recorded symptoms. For importing data into GABM, we need to create an Excel sheet. The Excel import template can be used for up to 10 cycles of 5 bridges. This facilitates bridge analysis for past inspection. Results for all imported data is reflected on the bridge screen within few seconds. All historical data, output screen and decision-making for latest inspection is available. Alert for bridges where inspection has not been done in the past 1 year also pops up. Similarly, the entire data of all bridges, including historical narrative, can be exported from GABM to the computer drive with one click of Export Data button under the Settings menu. GABM will seek the location where you want to save your data. Transfer will happen in few seconds. The exported data is properly structured in an Excel sheet. For the first bridge, all iterations are recorded year-wise. The data for one iteration is in one row, making it easy to read. Bridge-wise, data is recorded in the Excel sheet. This enables easy transfer of entire database from GABM to other utilities. Returning back to the GABM bridge home screen, one has the listing of all bridges. For every bridge you have the historical narrative, output screen for latest inspection and the decision-making process screen available at the click of the respective buttons. Select the bridge for which you want to review the historical details. Click the History button. The screen will display historical narrative of the recorded input data and output results for each of the inspections done in the past. The availability of historical narrative on one screen helps us understand how the bridge structure is deteriorating and also how the ratings have improved once remedial intervention have been provided. Efficiency of remedial intervention is evident on this screen. The decision-making process screen is available for the latest inspection conducted. Hereunder, one can review the entire analytical processing of raw inspection data. This includes statement of criticality under various conditions like functional efficiency, socio-economic importance, financial constraints, age-related issues. It also allows the user to define the remedial intervention for main causes of distress propagation. For this process to be completed, the user can determine the remedial intervention principles for 3 main or principal causes of distress. For each principal cause, GABM provides options for principles of remedial action. This choice is based on principles defined under EN 1504. Once the principle is chosen, the user can decide on the work methodology for implementation. This renders user being in full control of the bridge remedial interventions and therefore can controls the budgetary constraints. Once the selection of remedial action is completed and saved, the entire decision-making protocol can be viewed and/or printed and saved as a PDF file for inclusion in the bridge inspection report. To review the entire decision process, one can scroll down the same page and view the results of the analytics tools of GABM. This offers the user a one-page summary of the bridge structure and provides the technical, financial and operational aspects that need to be considered for final decision regarding allocation of funds for this bridge. Important aspects essentially required to be considered in decision-making protocol are analyzed efficiently. Returning to GABM Bridge home screen, your attention is drawn to alerts available on the home screen. Alert for bridge inspection due is provided to the user. This ensures compliance of the user to the requirements of conducting bridge inspection every year at least once. In case the regional authorities require the inspection to be conducted once in 2 years, the modifications can be applied in GABM. Should any alert pop up for a particular bridge, an inspection is conducted, data can be inserted for that bridge by simply using the Add Iterations button. The bridge identity screen pops up and the user can complete the inspection process. 2 functionalities are optional in GABM. First is the use of artificial intelligence tool to determine the structural ratings and cause matrix based on symptoms, and the second is conducting risk assessment for natural hazards. If you opt for using these functionality, the location details of the bridge are required to be recorded. Once you record these details and the details of various types of symptoms like cracks, crazings, delamination, spalling, deformations, and all other symptoms including the location details, GABM artificial intelligence tool determines the probable structural ratings and cause matrix ratings for the bridge structure. The final authority rests with the user to accept the suggested ratings or to change them as per their expertise. This tool during evolution has undergone multiple machine learning iterations to fine-tune the integration of artificial intelligence with GABM. Statistically, this tool will deliver near normal results, but exceptional scenarios can require modifications. These changes in ratings can be implemented by the user during actual field inspection of the structure. Normally 4 images can be uploaded to GABM for iterations. So in the first inspection, overall view of the bridge structure, close view of typical symptoms, 3D model view, and photogrammetry images generated by the software used by the user can be uploaded. Subsequent inspection, the user can upload images of progressive increase in distress and photogrammetry results. GABM allows user to upload images in standard JPEG format from any software used by the user. For application of risk assessment for the bridge, the user will need information about the region and data related to the historical narrative regarding the natural hazards. Their occurrence details, severity details, and impact of natural hazards on the network of the region. Based on this regional data, GABM is capable to evaluate the risk index due to the combined impact of 4 hazards on existing bridges, accounting for the individual bridge deterioration level. Prior to total evaluation, the user is provided an opportunity to correct the input data for this inspection process. Once it is confirmed, the results are generated for the entire inspection process. Risk index evaluation is the first step to empower users to understand how much efforts are required to ensure resilience of bridges in the network. The output screen will pop up within few seconds of the user confirmation of correctness of the bridge data. Output screen will show all essential information related to the bridge resultant on the inspection conducted. GABM ensure due diligence for technical requirements, financial constraints, sustainability and risk assessment included. Most of the emphasis is on technical due diligence, and results for balanced service life evaluation process with performance-based analysis is also available. If performance is not conducted by the user, the same will not be available. Full life cycle cost analysis for the bridge is done. The user can familiarize themselves with the assumptions of the LCCA process. MND2RB imply management for navigating from deteriorated to resilient bridges, which is an online tool that uses data from GABM. Export data functionality of GABM ensures compatibility between the two applications. Being online, it allows multiple viewers to view the content and analyze the same as per the viewer perspective. Once data is imported in MND2RB, the online platform report module allows viewers to choose the bridge from a list of bridges and the inspection date as per year of inspection. Then the viewer will be able to view the generated report for that bridge. The bridge report is generated from the imported database and narrates the bridge structure data and the analytics of the bridge structure. The report also has all the generated results which highlight the technical aspects, financial due diligence, the decision-making protocol. If the PDF files detailing the historical narrative of all the bridges are imported with the images, the same can also be included in the bridge report. Apart from multiple viewers being able to view the report, further analysis is possible by the graphics generated in the report module. GABM offers financial due diligence for the entire life cycle of the bridge. Decision-making protocol ensures fund optimization by providing enhanced efficiency in priority process. Technical requirements of the bridge structure are given due importance in the primary analysis. Further modifications to provide for change in importance can be provided. Ease of usage, very friendly user interface, technical and financial due diligence arising from exhaustive engineering research makes GABM versatile and a technology marvel. Being internet-free and standalone application, it offers flexibility and cost efficiency. UBMS Research Group focused research accords holistic perspective and integration of innovative technologies embedded into GABM makes it the most advanced bridge management system. The versatility of GABM renders a vast user base which can optimal usage of GABM. Municipal corporation for megacities and even mini-cities, toll plaza network operators, concessionaire of highway network, bridge inspectors and consultants, bridge owners with multiple field offices dispersed over large areas, regional and federal governments department can use GABM to efficiently manage their large inventories or micro-inventories. This is the only bridge management system that incorporates 3D model and photogrammetry imagery, symptoms, cause and performance-based dynamic evaluation process, along with risk assessment for natural hazards. GABM is a very efficient first step to help navigate from deteriorated to resilient bridges. All are invited to align their own bridge management objectives with the versatility of GABM. URG continues their journey of evolution to enhance the frontiers of bridge management globally.